Okay, today's integral is not actually so bad, so long as you remember your trig identities. So the integral is from negative pi over 4 to pi over 4 of 1 over 1 minus sine x. And the first thing we're going to want to do here is multiply by the conjugate. So that means, in this case, we're going to multiply by 1 plus sine x over 1 plus sine x. And in doing that, our integral will change to 1 plus sine x over 1 minus sine x times 1 plus sine x. Now notice, the denominator is 1 minus sine x times 1 plus sine x. If we check our formulas over here, a squared minus b squared is the same as a minus b times a plus b. And that's exactly what we have here in the denominator, where a is 1 and b is sine x. So in terms of the formula up here, we have the expanded version on the right, so we're going to replace that in our integral with this more condensed version on the left. This is our difference of squares formula, if you remember that. So our integral will change to the integral from negative pi over 4 to pi over 4 of 1 plus sine x over 1 minus sine squared x dx. And if we check our second formula up top over there, 1 minus sine squared x is the same as cosine squared x. So let's just write that in our integral now. So 1 plus sine x over cosine squared x. Things are a little simpler now, so what I'm going to do is actually split this into two different fractions. So the integral from negative pi over 4 to pi over 4 of 1 over cosine squared x plus sine x over cosine squared x dx. Now I'm going to take everything up here because we're out of room in our normal spot down there. And what I'm going to do is simplify a little bit. So it's still the integral from negative pi over 4 to pi over 4. But 1 over cosine squared can be rewritten as secant squared x. And then still plus sine x over cosine squared x dx. If we try to integrate all this now, integrating secant squared is really easy. That's one of the first integrals we learn. It's just tan x. This one on the right is a little bit more difficult, where we would do a u substitution. U equals cosine x and du equals negative sine x dx. So if we actually were to integrate, it would end up being minus the integral of 1 over u squared. And if we integrated that, integrating 1 over u squared would give us minus 1 over u. These two minus signs here would combine to a plus, and then just back substituting, we would get 1 over cosine x. Lastly, 1 over cosine x is the same as secant x, so we're just going to write that as secant x. And the reason I did that all fast was so I didn't have to take up a bunch of space changing all the bounds and stuff, because we want to plug it in all at once, from negative pi over 4 to pi over 4. So, plugging our bounds in now, we will have tan of pi over 4 first. Now, tan of pi over 4 is the same as sine of pi over 4 over cosine pi over 4. Sine of pi over 4 is root 2 over 2, and cosine of pi over 4 is also root 2 over 2. And because cosine pi over 4 is root 2 over 2, that means secant of pi over 4 is 2 over root 2. Now we have to subtract, plugging in the lower bound, and it's almost the same exact thing here. Now sine of negative pi over 4 is actually negative root 2 over 2, so we're going to change that there. But cosine of negative pi over 4 is still just root 2 over 2, and therefore secant of pi over 4 is also just 2 over root 2. Now if we simplify this further, root 2 over 2 over root 2 over 2 is just going to be 1. I'm going to leave our 2 over root 2 as it is right here. And now over with this part, let's distribute this negative into both of these terms. So for the first term, negative times a negative is a positive. So we're going to be adding root 2 over 2 over root 2 over 2, which we said over here is 1. So we're adding 1. As for our second term over here, this is positive, but we're distributing the negative. So we're subtracting here. And before we just left this as 2 over root 2. So I'm going to do that again. Just 2 over root 2. And now notice, we have 2 over root 2's. One's positive, one's negative, so these cancel. We also have 2 1's. They're both positive, so they're going to combine, giving us our final answer of 2.